Mark your own, here we go. Gotta have my favorite student, good old Anne. So number one says find the net force on charge Q3. So these two charges here are also exerting forces on each other. I don't care. That's not what the question asked for. The question wants to know what's Q3 feeling. So what I'm going to do is I'm going to find the force from charge 1 on charge 3. Magnitude and direction. So since I'm going to include a direction, I'll even put a vector sign. I'm not that fussy, but I may as well make it look right. Then, Declan, I'm also going to find the force from charge 2 on charge 3, magnitude and direction. I know charge 1 and charge 2 are pushing on. I don't care about that. Coulomb's law says K, this is going to be Q1, Q3 over R between 1 and 3 squared. It's going to be 9 times 10 to the 9th. Q1, I'm not putting the negative in. I'm going to use the, it's microcoulombs, 10 to the negative 6. I'm going to use the negative to figure out what the direction is by using like charges repel. Pause while I have a... I don't put the negative in. I use like charges, Kevin, and unlike charges attract, but I don't put that into the actual equation. I'm also not going to put the negative from Q3 in. All over, and then I want this distance here, which is 1.2 plus 0.6. Pretty sure that's 1.8. Don't forget the squared. I have no idea what the answer here is. 9 times 10 to the 9th, 2.5 times 10 to the negative 6. Got another latecomer interrupting my lesson. So 9 times 10 to the 9th times 2.5 times 10 to the negative 6 times 2.4 times 10 to the negative 6 divided by 1.8 squared. I get 1 point, I'm going to write it as 1.67 times 10 to the negative 2. Is that correct, folks? Or am I wrong? Really? I see someone nodding, but they're also writing like mad as though they're copying this out. I'm right? Okay. 1.67 times 10 to the negative 2 newtons. Direction. What direction is this charge feeling a force because of Q1? They're like charges, so it's feeling a force to the right. Now I'm going to repeat for charge Q2 and Q3. It's going to be Q2, Q3 over the radius between 2 and 3 squared. It's going to be 9 times 10 to the 9th. Q2 is 3.2 microcoulombs. Q3 is still 2.4 microcoulombs. But this distance is 0.6 squared. The nice thing is I should be able to just backspace and edit and just change a few numbers because I like the 9 times 10 to the 9th. I want this to be a 3.2 and I want this to be a 0.6. And now I think I'm good. I get 0.192, much bigger force. Newtons. Direction, this is going to pull it to the left because unlike charges attract. So how am I going to add these two together? Lost my calculator. How am I going to add these two together? I'm going to go winner minus loser. It's going to be 0.192. I'll go answer button. And then minus 0.01. And I'll just do a bunch of sixes. That's pretty close. And I get 1.75 newtons. Let me write this out. So final answer equals 0.192 minus 1.67 times 10 to the negative 2. It equals 0.175 newtons. Let me double check to make sure I've rounded off properly, Mr. Dueck. I have. Direction, which direction is winning? Left. Is that correct? If that's correct, that gets you 7 out of 7. Otherwise, I would go 1 mark if I saw this, 1 mark for the numbers. Actually, what I would probably do is this. 1 mark for the numbers. I would go 1 mark for the magnitude, 1 mark for the direction. 1 mark for the numbers, 1 mark for the magnitude, 1 mark for the direction, and then a half mark for that, and a half mark for that. That's probably how I'd give up 7 marks. Then I would turn the page. Now we're finding the electric field. So the electric field, symbol capital E, and yeah, we're running out of letters and having to reuse letters. The electric field, it's the force divided by the charge. That would be if I knew the force right there and the charge right there. I would use that one. I don't know that. Instead, I'm going to use the calculation for electric field that I use when I know the planetary charges that are sending out the electric field and how far away I am. I'm going to use K Q1 over R1 squared. I'll call that electric field number 1. And then I'm going to find the electric field from charge 2. That's going to be KQ2 over R2 squared. It's going to be 9 times 10 to the 9th. Q1, I'm not putting the negative in, 5 microcoulombs. And it's going to be 1.5, don't forget the squared. 9 times 10 to the 9th, 5 microcoulombs divided by 1.5, don't forget the squared. And I get an electric field of 20,000. I told you typical electric fields for microcoulombs are in the thousands or tens of thousands or hundreds of thousands. So that seems ballpark right to me. I'm going to go 20,000. Units are newtons per coulomb. Direction, we don't use like charges. Instead, we ask, which way would a positive charge right here feel a force because of Q1? I think it would get attracted to the left. So this one has an electric field pointing left. I repeat, for charge 2, it's going to be 9 times 10 to the 9th, 3 microcoulombs, all over 0.85. Don't forget the squared. This one won't work out evenly. Yuck. But I can backspace and edit and save myself some typing. Looks like it's going to be 3 microcoulombs and 0.85. I get 37,370 and change. 37,370 newtons per coulomb. Direction, which way would a positive feel a force because of this guy? Also left, because like charges repel. So this is going to be left plus left. I can do that. In fact, I can probably do this in my head. 37,000 plus 20,000. I think it's going to be 57,000. So I'm going to say the electric field, oh, I didn't put a 2 there. There we go. The electric field is going, come here, Mr. Dueck. The electric field is going to be, what? 57,400, I think if I go to 3 sig figs, newtons per coulomb left. For 7 marks, I would probably go 1 mark for the numbers, 1 mark for the value, 1 mark for the direction, 1 mark for the numbers, 1 mark for the value, 1 mark for the direction, half mark for that, half mark for that. Can you give yourself a score, please, out of 17? Out of 14. Any lawyering with me? Now is the chance to ask.